Hey everyone, welcome to KSSP Podcast. I am Spencer.
I'm Katie. And today we are going to be talking about black holes. I have an article and we've got a couple videos lined up as well that we're going to watch. This is from the University of Maine. This is 10 fun facts about black holes. The first one is you can't see directly into a black hole. So basically you can't see into a black hole because it absorbs all light that would reflect it on it. So that's interesting for sure.
Yeah.
Our Milky Way probably has a black hole. It should be in the center of the galaxy, I believe. That big white thing in the center when you look at the pictures of the galaxy. And then dying stars lead to stellar black holes. So the death of a large star would lead to a black hole because the star's gravity overwhelms the star's natural pressure that it maintains to keep its shape.
That is so interesting.
Yeah, the gravity just collapses the star's core.
Gravity.
The star's other layers are thrown off into space, and this process is known as a supernova. I've always wanted to see one of those. I think it'd be really cool to see that in the sky.
A supernova?
Yeah.
Safely?
Of course, yeah. There are three categories of black holes. We have primordial black holes, the smallest black holes, I guess, and they can range from the size of an atom to a mountain's mass. And then we have stellar black holes. These are the most common, and they can be up to 20 times more massive than the sun. And there's a variety of these all over our galaxy. Then we have supermassive black holes, the largest of all the black holes, being more than 1 million times more massive than the sun, which is crazy because the sun is already so much bigger than Earth. I can't imagine how big a supermassive black hole would be.
Yeah, and you wouldn't even see it. Like, I'm assuming you wouldn't see it.
Right.
You'd just run in.
You might see the light around it.
Yeah.
But
like
you wouldn't see it directly.
What do you call that? I don't even know. Just like a outline almost of...
Yeah. Yeah, I get what you're saying. Yeah, like the light around it.
Would outline the...
Outline it.
I don't know if there are even actual circles per se. It could probably be any shape. I don't know.
Yeah, I would assume they would be somewhat circular just because the way that gravity works.
Oh, yeah, okay. Like it pulls down.
Yeah.
Or maybe not down, I guess, but just like
it
to
like
the center in a sense.
Yeah, there would be a center and then everything surrounding. It might not be completely even, but it'd be somewhat circular.
Yeah, that makes sense.
And this fact just says black holes are funky.
Mm-hmm.
Interesting. So for a person who falls into a black hole, time slows down relative to the person watching. And time is affected by how fast you are going when you're at extreme speeds close to light.
So the person being sucked into the black hole, their perception of time is slowed down. Is that what that's saying? Or is it
It would be the person watching. Time's like watching them, they would be in slow motion, I think is what they're trying to say.
Okay.
That's what it sounds like to me, at least. The first black hole wasn't discovered until X-ray astronomy was used. Interesting. And the closest black hole is probably not 1,600 light years away. It's actually about 20,000 light years away, which is good. I'm glad it's not as close as we thought.
Then we're safe, right?
For now. And we don't know if wormholes exist, since we don't know too much about the physics, but that also means that anything may be possible. So,
I like that.
Yeah, the best way I would explain a wormhole would be like a passage through space-time, like almost like a teleportation hole through space or time or both. Yeah, and black holes are only dangerous if you get too close. Obviously, which also means that it's unlikely for a black hole to consume an entire universe. Interesting. Black holes are constantly used in science fiction. I don't know if that's a fact. I mean, it's a fact. I guess. I guess they just ran out of ideas.
Yeah.
On there.
Hey, you know.
So first, we have a National Geographic video, and this is just Black Holes 101.
Black holes are among the most fascinating objects in our universe. And also the most mysterious. A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return.
I think that's what you were talking about.
Yes, I think that's what I was talking. Like the event horizon is probably where you would see the light. Then I'm assuming, then you could see the outline in a sense of the black hole. I guess
really see the black hole itself.
No.
Beyond which we truly cannot see. When something crosses the event horizon, it collapses into the black hole's singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply.
Interesting.
Scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. Stellar black holes form when massive stars die and collapse. They're roughly 10 to 20 times the mass of our sun and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our sun. Scientists can only guess how they form, but we do know they exist at the center of just about every large galaxy, including our own. Sagittarius.
I'm kind of curious now if there's any theories about how supermassive black holes form.
Especially the fact that there is one at the center of every galaxy is interesting.
Yeah.
Or at least like the theory.
Not every galaxy, but they're at the center of galaxies, so I think. I don't think
that's interesting though.
Yeah, and this says some people have suggested that supermassive black holes form out of the collapse of massive clouds of gas during the early stages of the formation of a galaxy.
Because if we were to remove the black hole from the center of the galaxy, would that disrupt the whole galaxy's gravity? Because I'm assuming it's kind of helping hold the planets and stuff close to it, which then those gravity helps hold everything close to it. So kind of like a domino cascade effect, I would assume. If
like the supermassive black hole just disappeared, we would probably just fling off into oblivion, because our solar system actually revolves around the center of the galaxy, just like we revolve around the sun.
Interesting.
Yeah.
So we are technically at least slightly, if not completely, affected by the black hole's gravity. Then, I'm not saying it like it's solely responsible, but it definitely would affect us if it disappeared. Like it would affect everything.
Yeah,
because then our galaxy falling apart would probably affect a bunch of other galaxies as well, and especially if parts of our galaxy starts flying into other galaxies.
Yeah,
and starts creating. That'd just be chaos overall. Interesting.
Sirius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our sun. Because black holes are invisible, the only way for scientists to detect and study them is to observe their effect on nearby matter. This includes accretion disks, a disk of particles that form when gases and dust fall toward a black hole, and quasars, jets of particles that blast out of supermassive black holes. Black holes remained largely unknown until the 20th century. In 1916, using Einstein's general theory of relativity, a German physicist named Karl Schwarzschild calculated that any mass could become a black hole if it were compressed tightly enough. But it wasn't until 1971 when theory became reality. Astronomers studying the constellation Cygnus discovered the first black hole. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.
See, I always wonder if black holes are wormholes.
I feel they could. I mean,
like once you reach the singularity, like does that bring you to a different point in space-time where the laws of physics don't apply?
I guess we'll only know if we give it a try.
It would be really cool to send a camera into a black hole that would like actually be durable enough to survive it somehow.
Or like a one of our telescopes or rovers or something like that.
Yeah.
Maybe too. Then we could, in a sense, control it when it's in there too and see if it still follows the laws of physics in there. If it doesn't get crushed, that is too, because of the gravity.
That would be the problem. But
we just need to invent anti-gravity, guys. Our gravity repellent, bug repellent, mosquito repellent.
That'd be interesting.
Put that in gravity.
Like something that always pushes force in the opposite direction of gravity.
Yeah.
That would be interesting, for sure.
Although I'm pretty sure we would, if we used it on Earth, wouldn't we just float up? Or I guess, I don't know. Because then we'd be repulsing Earth's gravity, which is holding us down. So then what? I don't know if we'd go. I don't know what would.
We'd probably just float, I would think.
Okay.
I'm not sure. I guess, yeah, we would keep going until we were outside of the effects of Earth's gravity. And then we would probably just float after that. That would be my guess.
Interesting. Gravity is a very interesting thing to me. Trying to process every little detail of it, but
yeah, and I've read theories that suggest that gravity might even be another dimension in a sense.
I definitely wouldn't be surprised if it was something that we just, because I don't think we've been able to like quote unquote measure gravity, like you know how we can measure wavelengths and stuff. I don't think there's a thing that we've measured for like an actual
measure gravity. There's a I think it's usually,
but nothing physical though, right?
I don't know about physical. I just know there's like mathematical equations that
there's math, but I don't think we have like you know how there's
way to measure gravity. I don't think exists now.
Yeah, because I think I was reading something where somebody proposed that there was and I don't think a lot of people liked this idea, but or maybe it just didn't have much founding. I don't know, a graviton, so like an actual like not element. I don't know. If you search, or what did you find?
I was going to say, I searched tool to measure gravity. They have a gravimeter. It's the measuring instrument of the gravitational field of Earth at specific locations. It works on the principle of measuring constant downward acceleration of gravity. 2 types of gravimeters, absolute and relative. So they do have something you can use to measure gravity. Interesting.
If you search graviton, does that, because in my head I do get that it's a force, but it still has to, in my head it still has to be something, like it can't,
the energy.
Like I feel like we always just describe gravity like we just are like gravity is and I guess that was also in a sense what we do with time, because we don't necessarily, like I can't reach out and touch time, although I feel like we should be able to in my head.
Yeah.
Like how can these things I just don't think we have the tools or the technology to actually see this stuff with us. Like, I don't know if that makes sense, but
see these things.
What?
We're not evolved to see these things.
Yeah. And maybe like that would have been too much information for this experience as a human, I guess. Like maybe experience on Earth, we don't need that.
I mean, we could evolve one day, like, and you know, if we're still alive in, you know, 1,000 years or 2, maybe we'll even evolve to be able to kind of see time in a sense.
Yeah, maybe. Or even just technology. We should be able to, I would think, invent some sort of, I don't have any ideas, but I would think in the future, somebody would maybe just build upon ideas of previous people's theories or thoughts and be able to come up with a solution maybe, or some idea that could work and give it a try, and then maybe it'll work, maybe not. But gravity and time are just like, I still feel like there's something there, like they're not just like, I know we just accept them as they are, but I feel like there's deeper. But if there's not, that's okay too. I'm not gonna spend my whole life stressing about it, I guess. But
yeah. Then we have a Vsauce video. I don't know if you've heard of Vsauce, but
I don't think I have. But
he's got a lot of interesting science videos. This one is travel inside a black hole, and this is basically what would happen if a human entered a black hole. I believe. I think that's what this video is about.
Okay.
Hey, Vsauce, Michael here, and today we are going to go inside a black hole. It's not going to be comfortable, but it will be pretty fun. Now, first things first, mathematically speaking, anything could become a black hole if you were to compress it into a small enough space. That's right.
That's what scares me about the science, though. I'm scared someone's accidentally going to create a black hole and it's going to engulf the entire Earth.
It could. Isn't that what some people are scared of with, what is that?
And what was it? Particle acceleration? Was that what it was?
Yeah, I just don't remember what it's called off the top of my head.
Like the Higgs boson? Is that what it was? Or is that?
I think
that was the God particle.
But it's the experiment that they used to find it. What is that called again? Or what's the machine called? Because they always made it out to be this scary. Like I think it's not a scary name, but it has a.
Oh yeah, the Large Hadron Collider.
Yes, the Hadron Collider.
Yeah.
Because they restarted that again, I believe, or maybe I don't know. That might have just been. It might have always been running, and they were just changing some study. I don't know. Yeah. I just know that there was this whole on TikTok, of course, that the end of the world was going to be happening when they restarted the Hadron Collider, but obviously we're fine. So
Yeah.
Or maybe we're not fine. Maybe it ended.
I don't see how colliding particles would create a black hole, though. But I mean, I guess okay. People have
Yeah, because you're not really compressing.
right.
That's
You're
more
just
so just creating energy in a sense.
yeah, but yeah, there's two situations. Either I don't understand this, or they don't understand this, or maybe both.
But I was like, yeah, maybe both.
Create a black hole, though.
Yeah, I don't know.
Me, this camera, everything in the universe has what is known as a Schwarzschild radius, a tiny, tiny amount of space that, were you to collapse the entire mass of the object into, its density would be so great that its gravitational pull would be so great that not even light could escape from it. You would have a black hole. If you were to compress Mount Everest into something smaller than a nanometer, you would have a black hole. And if you were to compress the entire Earth down to the size of a peanut, you would have a black hole. But fortunately for us, there is no known way to compress Everest or Earth in that fashion. But a star, many, many, many times larger than our own sun, has a much larger Schwarzschild radius. And when it runs out of fuel and can no longer keep itself hot enough, it collapses to a single infinitesimally small point known as a singularity. Its density will be infinite, and so its gravitational pull will be so strong that nothing can escape, not even light. But enough about ways black holes form. Let's jump into one. First question, what would it look like from the outside? Well, we know that gravitational fields bend space and time. Stars behind our sun will actually appear to be in slightly different locations from Earth because the sun's gravitational field bends the light coming from those stars. When it comes to the gravitational fields of larger objects like entire galaxies, or for that matter, a black hole, the effect is even nuttier. Light coming from objects behind them is significantly distorted, producing smears and smudges. As seen from Earth, the blue galaxy behind this red galaxy is completely distorted, like a fun.
Okay, so here's Earth, the blue galaxy. I want to understand this here.
Yeah.
So, okay, basically all this gravity is distorting where the blue galaxy is, like seen visually. Let's see. Light leaves a young star-forming blue galaxy near the edge of the visible universe. Some of the light passes through a large cluster of galaxies and surrounding dark matter directly in the light of the sight between the Earth and the distant galaxy. The dark matter's gravity acts like a lens, bending the incoming light. Most of this light is scattered, but some is focused and detected towards Earth. Observers see multiple distorted images of the background galaxy. Oh, so, okay, interesting.
House mirror. So rather than appearing as it really should, it looks to us like a ring, a smudge all the way around the red galaxy. This is known as gravitational lensing. Now take a look at this simulation of a black hole with a galaxy millions of light years behind it. The galaxy is not really in danger of the black hole's suck, but the light coming off of that galaxy certainly is. Watch as the galaxy passes behind the black hole, and its light is contorted, twisted, and distorted. Now here's a really fun demonstration. What if the Earth were to orbit around a black hole? Looking from the outside, the Earth would look normal at first, but as soon as it passed behind the black hole's gravitational field would warp the light reflecting off the Earth, producing this.
Whoa.
For the sake of simplicity, let's jump into a simple black hole, one that doesn't have a charge and isn't moving, and also isn't already sucking up a bunch of matter, so it's just there on its own. As we approach, the distortion of the sky grows greater and greater. A larger and larger portion of our field of view looking forward into the black hole will be filled with darkness. At this point, where half of our field of view has been swallowed up in darkness, we have reached the photon sphere. At this point, light is not going to necessarily get sucked into the black hole, but it doesn't necessarily leave it either. Instead, at this magical point in space, light, photons, can actually orbit the black hole. If you were to stop here for a moment and look to the side, you could theoretically see the back of your own head, because light reflecting off the back of your head would travel all the way around the sphere of the black hole right back to your face. A gravitational field not only warps space, it also warps time. Now, for most intents and purposes here on Earth, we never have to worry about that. But near a black hole, gravity would be so strong that an observer standing, watching you jump into the hole, would see something quite strange. They wouldn't see you get sucked quickly into the hole. Instead, they would see your approach become slower and slower and slower until you reached a point known as the event horizon.
Yeah. Now I know about spaghettification a little bit, as they call it in the field, where like your body would stretch out.
Oh, like, okay.
Spaghetti.
Huh.
I know about that. That's about the extent of my knowledge here, though. I don't know if he's probably going to talk about that, though.
This is a point in space where, once crossed, there's no going back. It is at that point that light can no longer escape. And so to a person watching you fall into the hole, that would be where your journey ended. You would seem almost frozen in space, the light coming off your body becoming increasingly redshifted until you simply faded into nothingness. They would never see you cross the event horizon. But for you, of course, everything would seem fine and dandy. You would continue past that horizon to your now inevitable death. As you continue to approach the black hole's singularity, your view of the entire universe would get compressed into a smaller and smaller point in space behind you. If the black hole we're jumping into is large enough, things might actually be quite comfortable at that event horizon. We'll know that we're never going to escape and that our lives are pretty much over, but it might take us hours to actually reach a point where things started to hurt. Why would they hurt? Well, the closer you get to the singularity, the more significant the difference in gravitational pull is across space. And so parts of me that are closer to the singularity would be pulled more strongly than parts that were facing away. And my entire body would be stretched toward the singularity. The effect would be so incredible. Scientists don't usually call it stretching. They call it spaghettification. Once you reach this point, you would be dead. Your molecules would be violently ripped and stretched apart. And when they got to the singularity, well, we don't really know what would happen. Perhaps they would completely disappear in violation of all the laws of physics. Or
I sometimes wonder if it even would hurt, depending on like what the laws of physics actually are inside of the black hole. You know, because no one's ever actually gone through a black hole, and no one definitely like came back to tell us about it.
No.
So like this is all theory.
Yeah, I don't know. I guess I don't really know, because obviously if we think on Earth, if someone was stretching our body like that, that would hurt. But I don't know, because then there would be all the gravity, like the increase. Like I don't know. I just don't even know if we would. It's hard to think about, I guess. Like I don't.
Right.
Because again, even like what they're thinking, while maybe based in science, we can't necessarily 100% say even this is going to happen if we go into a black. Like we can definitely say with strong certainty this is what we think is going to, but we will never truly know unless we go into a black hole.
Right.
I mean, I'm not saying I'm volunteering, but
Right.
I'm just saying we can make all the theories we want, but we'll never know until we go in there. So
Exactly.
or send something in there.
Yeah.
Although we said the closest one was 20,000 light years, right?
Yeah.
So I don't know if we'll be able to.
So that'd be like 20,000 years traveling at the speed of light to get there.
So we'll probably never know unless a human maybe were to develop technology faster than light, or if an alien species reaches out to us and gives us technology that allows us to travel super fast.
And also, wouldn't it be cool to just see the whole universe though?
Like in the event, like when you're going through the black hole?
Yeah, because
that would be.
The universe gets smaller and smaller.
And like how you can see the back of your head.
Yeah.
Because that'd be interesting.
Seeing 360 vision.
Yeah.
That would be cool.
That would.
Or maybe they would reappear elsewhere in the universe. It's believed that a moving or spinning black hole might actually create what is known as a wormhole, a way of transitioning across faster than light. Not in any way that violates the laws of science, but in a way that takes advantage of the universe's dimensions. For instance, if I wanted to get from this point to this point, I'd have to travel the distance. But theoretically, a wormhole would do something really crazy. For instance, this. Now, the 2 points are right next to each other, and I can travel between them almost instantaneously. But again, this is all theoretical. Luckily, we do have a possible way of analyzing black holes right here on Earth. Enter the dumb hole. Just as a black hole does not permit light to escape, a dumb hole is an acoustic black hole. It won't allow sound to escape. It doesn't have to be nearly as powerful. And scientists have been able to create dumb holes in laboratories using special fluids traveling at the speed of sound. A lot of progress still needs to be made in the world of acoustic black holes, but we may be able to learn an amazing amount of information about how black holes work by looking at how sound is treated in a dumb hole. Now here's another good question. What would it look like to travel at the speed of light, say, toward the sun? Well, surprisingly, you wouldn't just see the sun immediately rush up toward you. No. In fact, initially, it would look almost as if the sun were receding away from you. Why? Because your field of view would vastly increase in size. You would be able to see stuff almost behind you. And here's why. As you sit there, not moving yet, looking at the sun, there's light coming from stuff behind you. But if you travel the speed of light, you will actually reach that light coming from things behind you. As you reached light speed, your field of view would expand like this, concentrating the stuff in the middle. But where are you in the universe? Or here's a better question. Where is the center of the universe?
Well, I know
Well, this might sound crazy, but it's everywhere. This is known as the cosmological principle. No matter where you are in the universe, everything else will seem to be moving away from you, expanding at the same rate. The universe is expanding, but not like a balloon getting bigger with all the people inside it. Instead, it's as if we are the surface of a balloon. If you were to put a bunch of dots on a balloon and then blow it up, all of the dots would move away from each other at the same rate. And on the surface of the balloon, there is no center. Take a look at these two layers. They are exactly similar, except the top layer represents a 5% expansion of the bottom layer. Let's say that you live on one of these dots, and you want to measure where everything's moving away from. Well, watch what happens when I line up a dot in the past and the present. Boom. It looks like the center of the expansion. I can do this with any dot. As soon as I choose a dot to be the frame of reference, it immediately becomes the center of the expansion. So while dying in a black hole would be lonely and scary and morbid, when you look up into the sky, think instead about this. No matter where you are or who you are or what your friends or your parents tell you, you really scientifically are the center of the universe.
Yeah,
Finally, what if our universe was a Googleplex meters across? It is nowhere near that large. But if it was, it would be so voluminous that statistically, it would be nearly impossible for there not to be an exact copy of you somewhere else out there in the universe. To see why, I highly suggest that you click right there and check out Brady Heron's new channel, Number File. It's part of the YouTube original channels, and I've worked with these guys before. They're amazing. They're my favorite kind of geeks. So check out that video, watch their other stuff, and if you like math, I highly suggest that you subscribe. And as always, thanks for watching.
Okay, so what did you think?
It's amazing. I don't really know. I guess it's hard to. I don't know. What did you think?
I thought it was super interesting.
Yeah.
Like,
do you have anything to?
I guess they covered a lot of stuff there.
They did.
But yeah, I mean, I'm going to just emphasize again, my personal belief, I guess, is that I do think that the black holes are probably wormholes. Now, whether they're wormholes within our universe or even to another universe is another question entirely. But
yeah,
that's just what makes the most sense to me, I guess.
If you had to explain it a little, what would be your rationale explanation for that? For your logic, I guess, do you use gravity or time or dimension? Do you use, when you're thinking about it, do you think of those things, I guess.
I'm thinking of it, especially like spatially and just the way that they describe what happens. Like the fact that it would almost be like a cone in a sense. Like, I don't know. I'm trying to visualize it here. Just going towards that singularity. I think, like, where else would you go? Like, I guess it just wouldn't make sense in my head for you to just disappear.
Yeah. No,
it wouldn't matter to just disappear.
Because isn't it true, unless this has changed, that atoms can't be created or destroyed? Isn't that a thing? Yeah, okay. And like the only other thing, I guess that would make sense is if your atoms became part of the black hole, which I mean, I guess that always could be a possibility, but that's boring.
Yeah.
Like you just get crushed to be part of the singularity, like no thanks.
Well, yeah, and just the fact that the black holes do warp space and time. I would think that they would warp into something. I don't know where I was going with that, but
I want to know more about gravity. I feel like gravity is obviously probably one of the biggest culprits in this whole.
Yeah, gravity is a huge part of it.
But I don't know. I just feel like still people will be like, it's just gravity. It's just stronger gravity. But what do you mean? Like what? That I just want to know.
Gravity warps everything.
I know, but like, why is it so much strong? Like people say, like they say, you can condense the Earth to a peanut, and then you have a black hole. Mm-hmm. But why? Like, what does doing that do to the gravity?
I think because all of that mass, the mass of the Earth is condensed into such a small size that it would collapse on itself
because of gravity.
It's not stable.
But gravity does that.
Because of gravity. Yeah, gravity is definitely involved in the process.
So like going from a big circle to a small circle, then gravity squeezes it even more?
Yeah, gravity, I think it would warp everything around it even more if the object is smaller, because it would be the same amount of gravity for the same amount of mass. But the size of that object affects how far the gravity is spread out, I guess, is the best way I'd explain it.
So it isn't more graves. So if Earth became the size of a peanut, there wouldn't necessarily be more gravity than what we have on Earth already.
Right.
Per se, in theory.
The gravity would be more dense, though.
And obviously every single human and every single rock and everything on Earth that is being held down by gravity wouldn't all fit on the size of a peanut.
Right.
But we would still be pulled into that gravity because we're pulled to Earth's gravity.
Right.
Right? Is that making sense? I don't know if that's making sense. But
yeah.
So then, I don't know. Because then obviously you have to think about Earth, or not Earth, just the universe in a sense being almost 4-dimensional, not 3-dimensional.
Right.
Because the black hole will also like almost invert itself into the universe. Earth is in a sense on top of the universe, but if it were to become a black hole, it would almost go in, like, I don't know how to explain it, but it almost goes into the universe.
Right.
Like into the 4th dimension, in a sense. I don't know if that makes much sense, but it's like, what?
Well, into another dimension, yeah. I don't know which one specifically, I guess, but
it almost makes like a hole, like a puncture through everything.
Yeah.
Because of gravity.
Right. It's just a hole with nothing in it. It's just a void.
So what if we had, I don't know, maybe not a weapon, but a device that allowed us to shoot gravity, and we shot gravity just into space somewhere? If it was strong enough gravity, could it create a black hole?
Do you mean like if you shot?
Or would it have to hit something? I don't know.
Gravity?
Because gravity's a force, right?
Yeah, gravity is a force that's centered around mass and acceleration.
So you could shoot, in a sense, like, because the acceleration from
you would have to
not a gun, but
mass, I think, but yeah, I guess you could potentially do that.
And then we would be creating gravity, in a sense.
I don't know if you can create that, but I think you can maybe harness the energy of gravity.
Okay. And then we would be able to make a black hole from that, maybe.
Yeah. Well, yeah, the black hole, you just have to condense something to a small enough size and retain its mass.
Yeah, I was like, can we even do that? Because when you cut like food in half, it loses half of its mass. So I don't know how you could even, like a watermelon, if you wanted to condense it to make a black hole, obviously we don't have the technology to do, not that I know of.
No, I don't think so. Like, I don't even think, let me look this up so I don't look stupid. have they condensed particles? Can you still see me?
Yes.
Okay.
Not your screen, but I could see you. So gravity, in theory, doesn't exist if there was no planets and no mass in the universe. Gravity wouldn't exist, in theory.
If there was mass, gravity wouldn't exist, right? Can't find what I'm looking for though on Google, but that's okay. Yeah, I don't really have much else to add.
Gravity just always confuses me still.
That's confusing.
I mean, I feel like it probably isn't as, like, I guess if you do say gravity is only with mass, and if there was no mass in the universe, gravity wouldn't exist, then I guess it simplifies it a little.
Yeah.
So then it depends. So then mass is if we wanted to create black holes or things like that, then mass is the variable we would want to mess with, not necessarily gravity.
Right. Yeah. Well, I guess it depends how you would do it. Like if you were adding mass to a condensed particle or something, I guess that would be one way to do it. Or the other would be to take something larger and then condense it to a smaller size.
But retain its mass. Like a shrink ray, kind of, or like a large ray or something like that.
Yeah.
And then gravity is more so just a byproduct then.
Yes.
It's not really a thing that we can, I guess, manipulate then without manipulating mass.
Correct.
In theory.
Yeah, or acceleration.
Yeah, I don't know. I guess that's all. I don't know anything else right now, but...
Right, I think we covered a lot today.
Yeah, I think that was good. So if you guys have any other topics that you would ever want us, science-y-ish topics that you want us to discuss or kind of look into like we did today, just leave a comment letting us know. You can leave a comment down on this video below.
Yeah, or you can leave a comment on our Instagram, TikTok, Facebook, and Twitter.
Yes. So we will see you guys next time.